JEE Advanced 2021, Paper 1, Question 17. Physics Charged Particles in Magnetic Field. Let us visualize the setup. Charged particles, initially at rest, are accelerated through a potential difference V. They gain kinetic energy and enter a region of uniform magnetic field B, directed perpendicular to their velocity, into the page. Inside this magnetic field, each particle traces a circular orbit. We have two particles, an alpha particle with mass 4 amu and charge plus 2e, and a singly charged sulfur ion with mass 32 amu and charge plus e. The question asks, an alpha particle of mass 4 amu and a singly charged sulfur ion of mass 32 amu are initially at rest. They are accelerated through a potential V and then enter a region of uniform magnetic field perpendicular to their velocities. The alpha particle and the sulfur ion move in circular orbits of radii r alpha and rs respectively. Find the ratio rs over r alpha. This is an integer type answer. The key concept involves two principles. First, when a charge q is accelerated from rest through potential V, the kinetic energy gained equals qv. So half mv squared equals qv, giving velocity v equals square root of 2qv over m. Second, inside the magnetic field, the Lorentz force provides the centripetal force for circular motion. qvb equals mv squared over r. This gives the radius r equals mv over qb. The particle curves into a circular path, with larger mass or higher speed leading to a bigger orbit. Step 1. Derive the general radius formula. We substitute the velocity into the radius expression. R equals m over qb times the square root of 2qv over m, simplifying, r equals 1 over b times the square root of 2 meters v over q. This is the key formula. The radius depends on the mass to charge ratio. Since v and b are the same for both particles, only the ratio m over q determines the orbit size. Step 2. Identify the properties of both particles. The alpha particle has mass 4 amu and charge plus 2e. So the mass to charge ratio for the alpha particle is 4 over 2e, which equals 2 over e. The singly charged sulfur ion has mass 32 amu and charge plus e. Its mass to charge ratio is 32 over e. Notice the sulfur ion has a much larger mass to charge ratio, 16 times that of the alpha particle. Step 3. Compute the radii. For the alpha particle, we substitute mass 4 amu and charge 2e into our radius formula. R alpha equals 1 over b times the square root of 2 times 4 times v over 2e, simplifying inside the square root, 8v over 2e equals 4v over e. So R alpha equals 1 over b times root of 4v over e. For the sulfur ion, mass is 32 amu and charge is e. Rs equals 1 over b times root of 2 times 32v over e, which gives root of 64v over e. Step 4. Computing the ratio Rs over R alpha. We divide the two expressions. The v over e and 1 over b terms cancel out. The ratio simplifies to the square root of 64 over 4, which equals the square root of 16, which equals 4. So the sulfur ion's orbit is exactly 4 times larger than the alpha particle's orbit. The answer is 4. The ratio Rs over R alpha equals 4. Using the general formula for radius in a magnetic field, the ratio depends on the square root of the mass to charge ratio. The sulfur ion, being heavier and less charged, traces a circular orbit 4 times larger than the alpha particle. Exam tips for JEE Advanced. Tip 1. For a charged particle accelerated through potential V and entering a magnetic field B, the radius formula is 1 over b times the square root of 2 meters v over q. Tip 2. When V and b are the same for both particles, the radius is proportional to the square root of mass over charge. This is a very useful shortcut for comparison questions. Tip 3. Remember that an alpha particle always has charge plus 2e, consisting of 2 protons and 2 neutrons. Tip 4. Always check whether an ion is singly or doubly charged. This directly affects the orbit radius. If you found this helpful, like and subscribe for more JEE Advanced 2021 solutions at MAGPIEHUB.